Alright, hello everyone. I'm going to go over the integral rules and show you how I remember them. Problem number one, if we integrate a function with a constant, we simply pull that constant out to the front and then just integrate this. If we integrate a sum or difference, we can integrate them separately. So you can just do them separately. That is fine. If you're integrating just to u, pretend that's a 1 there. And then you're integrating that, well, it goes back to u. But don't forget, now that we've done integration, we have to put the constant on there. And then always check everything with derivatives. The derivative of u is just 1, and the constant goes away. This is reverse power rule. Add 1, divide by what you add, plus c. Have to make a note here. N cannot be -1. Because if n is -1, now it looks like this, right? If I have u to the -1, that's 1 over u. And if I add 1 to it, that's 0. Dividing by 0 is undefined. So you have to make sure you have this condition for the power rule. What is the integral of 1 over u? Well, if its derivative is on top, that is just the natural log of u plus c. We put the absolute value because you can't take the log of a negative number. Now, just remember, just always think back to your derivative rules. If you take the derivative of natural log, well, that's 1 over x. We talked about that when we were doing the derivative rules. So you got to match the two up. E to the u. This is the easiest one there is, right? Just e to the u plus c. On this one, it's very similar here. So it's still a to the u. However, now we're going to divide by the natural log of the base, and we're going to make sure we add a plus c on it at the end. So you have to make sure you have all of those parts there. On number 8, because when we take the derivative, we multiply it by it. But when we take the integral, we divide by it. Integral of sine. Sine goes to negative cosine. And again, just remember, if you take the derivative of cosine, you have a negative. Those cancel out. Well, this one is just regular. Sine goes directly to cosine. Tangent. Now, how did we do tangent? Well, if you remember how we did tangent, we came over here and said tangent is sine over cosine. And then we did some u sub and said u is equal to sine of cosine, or sorry, u is equal to sine of u. And then when we take the derivative, we have du dx is equal to negative, or sorry, my fault. If you let it equal cosine, the derivative is negative sine of x. So now we have this, so we can take this and put this in here, and now it just becomes a -1 over cosine x. So by doing this u substitution, we can turn it into just -1. So this is really just the integral of this, and that's a log. So if you ever wonder where the negative comes from and where the log comes from in this one, well, the negative comes from this derivative here, and the log comes from when we integrate 1 over cosine. And how did I get to 1 over cosine? With some u sub. It's a little bit messy here, but that's where the cosine comes from. And you can do the same kind of logic. There's some proofs that you can do to do the same thing here. But I always go back to this first one and I get cosine because I can do it this way. And then if you do that, you can get the other ones. All right, secant. Again, it's just a different version of it. Cosecant is again a different version of that same natural log one. But then we get back to one that we know, and that goes to tangent. That comes straight from a derivative rule. This comes straight from a derivative rule. and this comes straight from a derivative rule. So these match your derivative rules, those don't. And 17, again, some more rules. And then we get back to our inverse tangents. And again, these are the sines and secants. And this one I know right away from the tangent one, right? And it's 1 over a inverse tangent u over a plus c. I just remember that arctan goes here, and the other two are the sine and the secant. And the formula here is just a simple one, arcsine of u over a plus c. And this one is the strange one, arcsecant u over a plus c. All right, that's how I remember my integral rules.